Welcome at this small clip about containers. We continue. There are two heights used in a container shipping. It's the standard height and the high cube. The high cube, you see it on the right with the yellow place marking. It's about 1 feet higher than the standard height. Sealment. Containers should be sealed while they are shipped, and there are three reasons, maybe there are even more. The risk of theft, stowaways inside the container, and terrorism. As you can see, there are multiple types of seals. The two you see now might be equipped with a GPS tracker so that during a shipment they can be followed by the shipper or by the customer. And for example, if we use a container for door-to-door transport, you can also calculate the ETA of the container to the consumer, to the customer. Fumigation, pest control. We use chemicals to fill up the inside of a container to prevent that, for example, small animals eat their way out of wooden furniture. So inside there's toxic gas killing these small animals so that the furniture, it's just an example, could be something else, doesn't get damaged by these small animals. And we call this fumigation or pest control. Also on board of bulk carriers, this is used, for example, if we ship grain, we should be aware of bugs, small animals eating grain, and we use fumigation there as well. This gas which is used is also dangerous for persons, so we should be aware of our PPE, personal protective equipment, in Dutch persoonlijke beschermingsmiddelen. Here you see a guy with a filter mask taking some measurements prior opening. Be aware of your safety. Usually the companies opening, closing and stuffing containers, they have procedures concerning ventilation and opening and PPE. Be cautious if this happens on board that you need to open it. Maybe use breathing apparatus while opening so. Stack loads. Luckily, the Morgenstund program gives alarm in the program if you exceed stack load. And stack load is basically if we have a tier of containers, so a vertical pile of containers, they're going to calculate what's actually the weight of the stack and the surface where this stack is placed. Is it able to withstand the full weight of the tier of the stack? And that's what we mean with stack load. So the container causes 4 point loads on the hatches or on the tank top or on the twin deck. Well, what does this imply concerning the design of the hatches? It's actually likewise compared to double bottoms of ships, that the stiffenings are aligned with the place where the container actually rests on. So you see the yellow foundations on the picture, and inside we can put a twist lock, and that's the position where the tier of containers will actually rest on. And underneath that position, where you place the stack loads, there's some stiffenings designed as such in the hatches of the ship. I have a small exercise for you. Please use the pause button. Check for yourself. Are we able to stack 4 20-foot containers at base 17? And these are the weights. Put it on pause. So there might be some commercial pressure on you one day as a chief mate to actually exceed the stack load. This is a dangerous thing to do. You should refuse to load and exceed the stack load. Here is a small image of the program we use for the Morgenstund. If you exceed the stack load, as said earlier, you will get a warning which you should confirm or deny. And also, in practice, you need to deny the container, so it's not actually stacked on tier number 86. Because if you do that, you exceed with 16 tons and it might damage your hatches. The ship can get damaged and unseaworthy, and you shouldn't do. Here's some other things which go wrong. I don't know the context of the picture on the left, but you see that the container broke. Probably it started at the bottom of the container. And still you see the spreader can hold the container on the corner castings, but the angle looks a bit nasty to me. This is the motor vessel Rena. It sailed on an atoll some years ago and it lost some containers. I believe the second mate didn't put the position into the chart correctly, and so that's why it ran aground. And the Sandborg Maersk, I don't know the cause of these piled up containers. Stowage, so we make tiers and the corner castings of the container we connect by twist locks. Here you see the twist lock in the middle and we can lock it. There are two types, automatic and manual twist locks. Here a bridge fitting, so multiple stacks of containers we can connect and that they stay to each other. Bridge fitting. Here's the twist lock. Please bear in mind that we have left lockers and right locker twist locks. This is a right locker because you can see the handle is to the right and the cone of the twist lock is in the closed position. If it's open, the cone will be flush with the foundation underneath, so something could pass over it. But now it's closed and this is a right locker because the pin is on the right. It's important that you never mix right lockers and left lockers on one ship because it will be very difficult for the sailors to see the difference while they actually lash or unlash containers, and you might risk actually that some tiers will be not fully closed and lashed according to the cargo securing manual. So it's dangerous. Never mix left lockers and right lockers on one ship. This is an automatic twist lock. It will be placed on the it will be placed at the bottom of the container. Then it will be lifted to its position, and then it can one time enter the top side corner casting of the container underneath. And if everything goes wrong, it will one time move the bottom foundation of the automatic twist lock, and when it actually passes through the corner casting, it will close and it will lock, and it can only be resetted by actually pulling with the handle on this little yellow lever. If something goes wrong, they usually need to be resetted all four, and it needs to be done ashore again. Automatic twist lock. So some overview of lashed containers, how many and how there should be lashed. It's actually written down in the cargo securing manual, and this is approved by a classification bureau. Here you see lashing bars and turnbuckles, lashing bars, and how to put them and how many is written in the cargo securing manual. Before departure, you check the lashings if it's tight enough, if we can leave seaworthy. Usually the installing of the lashings will be done by a shore gang, but you are responsible as an officer, captain as well, and you should check prior sailing. During the trip, the officer and the ABs, they daily check the lashings and they retighten the lashings. And weather-dependent lashing, it sometimes will be done if there's a very short sea voyage and you have an exact and accurate weather report. You might be allowed by class bureau to have less lashings on the ship, and you save some time and money. Sorry, but it needs to be approved by class bureau. You will see this sometimes on ferries, for example, between Dover and Calais. It's only a 45-minute sailing, and if you have a weather report and it's accurate, you can actually decide to less a bit less. So if we make a stowage plan on a container ship, we also 9 out of 10 times bring dangerous cargo on board inside these containers. We need to check prior making the stowage plan where we will put these dangerous goods. We actually first need to check the document of compliance for carrying dangerous goods of the ship itself, and we need to check if we can place something at a certain position. For example, cargo hold number 7, it's close to the engine room. There might be some restrictions over there because it's close to the engine bulkhead. In the overview, you see there's a distinction between the weather deck and inside the hold. It's fully enclosed there inside the hold. There's much less natural ventilation. So there are other and severe risks if you have something in a gas state over there. Yeah, another example which is important is the vicinity of air intakes. For example, they are most likely close to cargo hold number 7 in the front of the accommodation or at the back. Underlying principle of this document of compliance for carrying dangerous goods is that it's based on risk assessment and the chemical risk of spill or leakage and the consequences of those. Usually we say risk is chance times effect. And actually, I should have started with this. The stowage category, it's actually a category which every dangerous good gets. It's the standalone risk of a dangerous good. So we not yet combine this dangerous good with another one. So it's just the single standalone on itself risk of a certain dangerous good. So if we're gonna combine dangerous goods, because usually we have more than one dangerous good on board of a ship, we need to be aware of the amount of distance between those dangerous goods. For example, on the picture, there's I believe it's the Hajj in Pennsylvania. It got on fire somewhere in the Arabian Sea, as I'm correct, and most likely some fireworks which were not declared correctly were close by to peroxides, class 5.1, and this actually spread the fire and the explosion much more rapidly than in case they would have stuck to the rules. So they were close to each other, and that actually set the blaze up a bit higher, more rapidly than normal. If we're gonna stow multiple dangerous goods on one ship or on one cargo hold, we need to be aware of the distances among each other, and we use the segregation table, and we're gonna do a bit more work with it in the lesson online. But what you see, there's a distinction between 4 groups. Actually, that's 5, and there's some severity starting with 1 away from to number 4, separated longitudinal by intervening complete compartment or hold from. So the heavier the risk, the bigger the distance, or the more something will be in between those cargoes. We're going to speak about verified gross mass, but it will be done in a separate clip. Thank you for watching.